Perfect. Okay. So here's a solution key for the homework. I'll post it to Schoology hopefully today. I'll get a chance this afternoon. Pretty straightforward for the first problem. Part A is asking you what easier equation could she solve to make the same solution you get from the original equation. So if you think about it, every single term in the original equation is a multiple of 1,000. So you divide every term by 1,000, you get 2x minus 4 equals 8. Pretty straightforward, right? No. I'm saying divide every term by 1,000, just to make it easier, right? Oh, I could then. Oh, so I see what you're saying. Sure, you could have done 2,000 also. That's fine. Yeah, you could have. You would have x minus 2 equals 4. Sure, that's fine. I just decided to divide by 1,000, but that works. And if you solve it like the way it looks, you get 2,000x equals 12,000, which is still 6. So you still get the same answer, obviously, as long as you simplify it correctly. Part C is a new equation, but there's a commonality. Every single term is divided by 50. Drop the 50. You should get 3 minus x equals 7. X should equal -4. So hopefully that makes sense how to simplify the equations. That should be pretty straightforward, right? So I guess that's 325. For 329, that's just review of old stuff, like can you distribute or FOIL? So part A, distribute the 2x, you should get that. Part B, x plus 3 times x minus 5 is x squared minus 2x minus 15. For part C, 2x plus 1 with x minus 3 is 2x squared and -5x minus 3. And D, if you're multiplying x plus 3 by itself or FOILing it with itself, you should get x squared plus 6x plus 9. So that's just review of old stuff. You guys should be okay with that. Any questions at all? Nope. All right, let's do 41. Oh, sure, yeah, no problem.
Is that on D? Is that last number of 5?
6x plus 9. X squared plus 6x plus 9. Yeah, plus 9. It kind of looks like a 5 a little bit if I curved it. Yeah, okay. I didn't close the loop on my 9. My bad.
Oh, but it's 2.
Yeah, just x plus 3 times x plus 3. Now for 41, this is solving literal equations, meaning you're trying to isolate a variable with multiple variables in the equation. In this case, they want you to isolate y. So what you could do is subtract 5x and divide by -2. That's all. Pretty straightforward. You could divide by -2 first, but then the problem with that is that then you have 5x over -2, and that just makes things a little more complicated. I'd rather move the 5x over first, then divide by -2. Likewise with part B, move the 3x first, then divide by x. Because right now I have x times y. X is a coefficient of y, if you want to think of it like that. But move the 3x first and divide by x. So hopefully that's straightforward. Sadie, go ahead. In the second one, you can factor out an x, but that kind of goes against what we want. I mean, you could do that and then divide by x afterwards. So I see what you're saying. You could do this. It's a little more roundabout, but sure. If you factor out the x, you get this. Now, if they ask you to solve for x, you totally have to do that. I don't know how else you would solve the problem. But since you're being asked to solve for y, then I'm going to divide by x and then subtract the 3. Hold on a sec. Let me minimize that. And it's still the same thing if you have 2 over x minus 3. I mean, but you just got to be careful, that's all. Sure, 329. Which part?
Like any of them, like review it.
Yeah, so let's look at C, because that's a little bit more involved. For C, you're going to have 2x plus 1 times x minus 3. And remember, first, outside, inside, last. That's the process we use. That's the acronym FOIL. So that becomes 2x squared. That becomes -6x. That becomes positive x. And that becomes -3. Clean it up. And you get that. Sam, go ahead.
I have a question for
Yeah.
341B. Like I saw you got the answer, and I was wondering why you didn't subtract like the -3x first.
Oh, the reason I did do that. -3x first. Yeah, I did.
So then when you divide by x, you got like
Yeah, I did.
-3x
Plus 2 over x.
Oh,
I did do that. No, what I was doing, I was modeling the way Sadie did. That's all.
Oh.
But that's how I prefer to do it. Just one less step. And sorry, I mean, did that make sense for part B? How I worked out part B? Sorry, part C, my bad. My apologies.
That's all you have to do is FOIL.
For number 20, for the previous problem, yes. For 329. Except for A is just distribution. Yeah, A is distribution. Technically, FOIL is distribution, just a more intricate distribution because you have two terms of two terms. Hence, we have an organized process called FOIL. Or you can use a rectangle, that works too. And combine like terms afterwards. Okay, let's move on to page 2. Page 2 is solving equations. So for A, I see an opportunity to distribute the n into n plus 2 in the middle expression. If I do that and then combine like terms afterwards, I should get n squared plus 4n plus 4. Factor afterwards, solve for n and get -2. For part B, that one's a little tricky. What do you think I did as my first? I didn't really show it, but what do you think I did as my first step for part B? You have 4 over x. How do you think I got rid of that x in the bottom of the first fraction? And that's really 3.
Use multiple x.
Yeah, multiply both sides by x. That becomes 4 and then x squared plus 3x. And then move the 4 over and factor. You should get the answer. But fractions are complicated, so let's uncomplicate it. Go, Demi.
Or then you factor out.
Exactly. Then I just factor like I would any normal trinomial. When you have like 3 terms, you know, what multiplies -4 adds up to 3, 4, -1. And then afterwards, each factor can be set equal to 0. Either x plus 4 equals 0 or x minus 1 equals 0. You get -4 or 1 from each of those situations. But for part A is -2. You get -4 and 1. Because when you factor x squared plus 3x minus 4, it's x plus 4 and x minus 1. Remember, you try and find terms that multiply -4 and add 3. So that's why it's 4 and -1. We're cool with that? Good. 50, always look for the GCF first. What's common among all 3 terms? A 5, an x, and a y. Pull them out. You should get x squared plus 7x plus 10. Factor that further. That should be pretty easy. 2 terms that multiply 10 add to 7. X plus 2, x plus 5. So again, factoring. And we're going to do some pretty intense factoring today. So get ready for that. Because we have to factor and simplify things afterwards. So no, you don't want to multiply them out because then you're going backwards. Yeah, you do not want to. You want to break it down as much as you can. And the reason why we want to do that is that when we start dealing with like more advanced stuff in pre-calculus or calculus, it's a skill that we need in our toolbox to just kind of say, okay, I can factor and I can do things more efficiently once it's factored. Fine for 96. This is a process called cross multiply. Today we're going to do something called cross canceling, which is a little different. But when you have equations, obviously you have equal signs, right? And you have one fraction on each side, you have the luxury of cross multiplying, meaning multiply 5 with m. Multiply 6 with m plus 1. Sorry, that's hard to read. But if you do that, actually, I'm not sure it's going to show up. Sometimes the highlighter doesn't show up very well on the screen here. And it's probably because I changed the contrast. Whatever. You guys get the point. You want to multiply 5 with m and 6 with m plus 1. And we'll work it out. You should get -6. B, rinse and repeat. 4, 3x minus 5, 2, 4x plus 1. C, rinse and repeat. K plus 3 with 8, K with 14. Sure. Let's do C. So what you're gonna do? Well, actually, let me do this. I need a little more. I'll do it down below because I need a little more space. Let me rewrite down here. 8 over K equals 14 over K plus 3. Okay, so let me lasso the ones I'm going to multiply together. There is. I messed with it, and it's actually it's off now. Yes, I can. I don't know if it's a bright. I think it might be the contrast. I'm just gonna make it worse or better. I think it makes it worse. That's what made it worse. I'm sorry. So maybe go the other direction. How about that?
Yeah.
There they are off, dude.
Wait, that actually looks. I just want to
Oh my gosh, look at that. Wow. That is so much better.
But I think you're turning it down.
I know, but you guys see it better?
I don't feel the difference.
Yeah,
Maybe you need to get glasses. I'm just kidding. All right, sorry, that's a little sassy. All right, okay. But can you guys see? All right, now, if you multiply 8 with k plus 3 and multiply 14 with k, you get this. And then you should get 8k plus 24. I'll do it up top because I'm running out of space. Equals 14k. And then you just solve after that, which is a very simple linear equation, which should get you 6k equals 24 or k equals 4. But that's called cross multiplying. Whenever you have an equal sign in between two fractions, you have exactly one fraction, nothing else. A fraction on the left side, a fraction on the right side. You have that luxury of doing that. It's the same effect as multiplying both sides by k, and then multiplying both sides by k plus 3 or vice versa. You're doing it simultaneously to kind of eliminate a step and just a cleaner process, because then it turns into a linear equation. Or it can be quadratic sometimes too. It just depends on what terms you have. But these were all linear, so it came out like that. Okay, we're good? Okay, cool. Sweet. So that covers the homework. Okay, so let's go through the notes. So you have 3.4, so you need to get your notes packet out. And we're gonna do 3.5. 3.4 is actually really easy. It's all about just canceling out. 3.5 is taking a little step ahead. It's canceling out and combining things afterwards. But for 3.4, they call it how can one be useful, meaning that when things cancel out, you just get the number 1. So let's take a look at 371. Sure, that's fine, not a problem. Go ahead, go for it. Sure, no problem. Yeah, I always make extra. Yeah. There we go. Yeah. Okay. Oh, what was that? What is that?
It's a homework. I'm so sorry about that.
Here we go. All right, perfect. Okay. So let's not worry about this guy's name, Mr. Wonder, whatever. Bottom line is that when you have two of the same thing in a fraction, 16x or 16x, you're just going to get 1, right? Because if you think about it, 16 over 16 times x over x, I mean, 16 over 16 is 1. X over x is 1. 1 times 1 is 1. So you just get 1. And states that x cannot be 0. Of course, he's right. What is this hypothesis? That they can't divide by 0. Is he correct? Yes. And y can't be 0? Why x can't be 0? Because you can't divide by 0. So it's kind of a lame question, to be honest. Of course it's 1, and of course the bottom can't be 0. We know that. Does that make sense? For parts A, B, C, they're all kind of intertwined. So that's all. Questions? No? All right. Part D. Let's consider the next situation. X minus 3 over x minus 3. Does this equal 1? Yes. And what must be excluded? X cannot equal 3. Does that make sense also? Okay. Cross off E. That's just kind of stupid. And then for F, if you think about it, Z over Z equals 1. I mean, that's pretty obvious. So of course that's true. If you have Z over Z times X over Y, of course it's going to equal X over Y. That's because these cancel. And they cancel because they're 1. So don't overthink these problems. They're incredibly straightforward. So let's look at 72. So before, hold on a sec. Before we do this, 2 of these functions can be simplified.
really don't equal 0.
So which ones can be simplified? Wholly 100% correct. Do you see why? They're the same thing. Right?
Oh, no, it equal. I was thinking the opposite.
Okay, no worries. What do you think? What do you think the other one is that can be simplified? The third one? Well, the third one can't because they're different. Okay, I thought you said it could be. The third one cannot.
Yeah.
Okay, sorry. I thought you said can. Sorry. How about the fourth one? Can that? Nope, because it just is what it is. The second one's kind of interesting. That's going to equal -1. And why is that? Yeah, exactly.
Oh, it's negative 2x.
Yeah, what happens is this. You have 2x minus 3. And I can factor out -1 from the bottom. So let's think about it. I'm also going to change the color now. So that's kind of different. A little nuts now.
Negative 3 over 3.
Color saturation.
If we had some test, we just like plug in a number.
What was that? Sorry, say again?
If we just had some test, we just like plug in,
What do you mean plug in number?
like x equals 2, and it's like.
Well,
Just plug it in and see if we can.
sure we could to verify. Okay, oh, so much better. Look at that.
Ooh.
I'm just improving this. This is sweet. All right. Good. All right. All right. Now we're good. We can see, we've got colors. It's awesome. Okay. Now, why is it -1? Because think about it. If I pull -1 out from the bottom, it's the same thing as 3 minus 2x. If I put it back in, I get -2x plus 3, which is the same thing as 3 minus 2x. But the beauty about this, now I have two identical expressions. 2x minus 3, 2x minus 3. These will cancel out, leaving me behind with 1 over -1. So that's what's left behind. I can cross these off. 1 over -1, of course, is -1. So you have that luxury. If they're reversed, you can still cancel. You just have to leave behind -1. Now, for the question below, is there an x value that doesn't work for each function above? The answer is yes. And I'm going to kind of tell you which one, what they are for each of these. X cannot equal 3/2. X cannot equal 3/2. X cannot equal -3/2. Then X cannot equal 3/2. Hopefully that makes sense. Because think about it, if I plug 3/2 into this one, that's 0. That's 0. That's 0. Of course, this one's a little different because X plus 3 is -3/2. So I'm okay if you just say that. Just tell me what's excluded. You don't have to actually write the domain. Just tell me what you have to leave out. Because you can't divide by 0. So you have to, when you simplify, you also have to be mindful of the fact that, hey, here's what it simplifies to, assuming that X is not equal to this. Just being thorough with your answer. Personally, I don't care if you, when you simplify, you state the exclusion. But if I ask for the exclusion, then of course, tell me what that is.
Wait, why didn't you put like a slash in the equals for it's not boring?
You know what? Because I forgot. It's Friday afternoon. Thank you, Alberto. You keep me sharp, dude. Thank you. Give me sharp. Thank you, Alberto. Yes, I should have done that. Thank you. I appreciate it. No, I need glasses.
Yes.
No, I need to just pay attention better. Okay, or I need more sleep actually. So I'll play trick or treat with my kids. All right. 74. Okay, again, pretty straightforward stuff. Let's do two kind of the easier ones. I think they're all pretty easy actually. But what do you think what do you think A is going to be? Yeah, just cancel. How about D? Nine x over 9x, which is what? Which is still 1. Remember, when you subtract, when you multiply fractions, you have to multiply numerators and denominators together. I mean, numerators together and denominators together. and then you can simplify afterwards. But you could have done this as well. When it was like this, I could have done something called cross canceling. Actually, use a different color for a bit of contrast. So, because you see here that 9 over 9, those cancel. X or X, those cancel. You get 1, 1, 1, 1. You get 1. Cross canceling could happen when there's a times in between. It's not cross multiplying, mind you. That's when you're solving an equation. We're just simplifying. So we can cross cancel. So this process is called cross canceling, which we're going to do frequently for the other parts. What about B? What happens here? X or X? Cancel, cancel, cancel. What are you stuck with? Okay, what about C? X minus 2's cancel, right? What are you stuck with? Yep, X plus 5 or X minus 1. Let's look at E. H over H. Just H times K. Yep. Let me get rid of the other stuff because I need some space now. No, you don't need to. It's not necessary. Yeah, it's not necessary. Yeah, that was 1, by the way. Okay, what cancels for F? Go ahead, sorry. Okay, no worries. Yeah. M plus 6 is cancel. Should get that. What about G?
You do the exponents first, right?
It's up to you. You can think of like this: 6 over 3 times. I need a little more space here. I would not do that actually. The reason I would not do that is you're gonna make it worse and really hard to figure out what to simplify to. I would actually do this instead.
Actually, n times n minus 2. Yeah.
Because what is n minus 2 squared? N minus 2 twice. And the reason why, so remember, these problems are written for an intention. It's intended that things cancel. So you could FOIL, you could, but you're not going to see what's going to cancel afterwards, unfortunately. N minus 2 squared is n minus 2 times n minus 2. Do you see another n minus 2 on the bottom? Can you cancel those out? Yes. That's what you want to do. So yes, Jim, you're right. 6 over 3 is 2. That's good. That's lovely. Then these go away. So what are you stuck with? And you can leave it like that. You don't have to distribute if you don't want to. If you do, it's fine. I don't care. But you should get that for G. And lastly, for H. It's up to you. I don't care. Yeah, I don't care. For H, what happens to 3 minus 2 x's? Cross that again. 1 over 4x minus 1. Correct. Good. Great. Awesome. Good. Okay, we're okay? All right, great. For 75, I'm going to skip parts A and B because it's kind of redundant. And C as well. We'll just go straight to part D. And actually, before we do part D, kind of sort of just actually no, let's actually before I do part D. What if I have something like this here? Okay, I want to make sure we're clear on this. Can I cross off those 4 x's? Good. I'm glad you said that. And here's the reason why. It is what it is. You can't do anything about it. It's stuck. You're stuck with that. Because here's a problem. If you cross those off, then you get -3/5, right? But the problem is that when you cross stuff off, that's like division. But the 4x is being subtracted by 3, and the 4x is being added to 5. What's the opposite of division? Multiplication. If 4x is being multiplied by 3 and multiplied by 5, yes, you can do that. Because, for example, what if I have 4 minus 3? Let me get rid of the x's. What would that be, guys? Yeah, 1/9. But if you cross off those 4s, what's going to happen then? You get -3/5. Clearly, one of these two is wrong. And which one's wrong? The one that's convenient or the one that follows the rules? Of course, the one that's convenient is wrong because we have to follow the rules. So you don't want to cross those fours off unless there's times, then you could. So you don't want to do that. Of course, yeah, go ahead. So with that said, let's look at part D now, the bottom of this page here. Part 1 of part D. Careful with this one, okay? You have x squared plus x plus 3 and x plus 3. Some people want to cross these off. And so, yeah, those are the same. No, you can't do that, unfortunately. So this cannot be simplified. If you wanted to solve it, you'd have to multiply both sides by x plus 3 and then work it out afterwards. We're not going to do that because that's not the intent of this problem. The intent is just to tell you can't simplify it. But here, you can. Because notice these go away. And you get one side equaling the right side, which is all good. I mean, of course, that's infinitely many solutions, or it's they call it an identity because left side's identical to the right side. But anyway, in that case, you can. That's because there's a times here. That's a multiply. But see here, that's a plus. What operator is the inverse of division? That's why you could cross off for part 2, but not for part 1. Okay. Oh yeah, 100%. Oh yeah. Yeah. Actually, that is a test question, Alberto. So thank you for. Yeah, it's going to be something like, yes. We're going to ask you to identify something that's wrong and state why. Yes, 100%. I'll get to that when we finish the notes today. Albert, you're just on it today, dude. Okay. All right. I think when I talk about your eyesight, I just motivate something in you. Okay. I'm just kidding. All right. All right. 3-5. Let's move on. So as I told you, that was really short. 3-5 is very close to 3-4. It's just an added layer. It's like, okay, let's talk about combined fractions after we cancel things out. So, but before I do, any questions on 3-4 at all? We're good? All right. 3-5. And we should be hopefully have some time spare at the end. We're making some great progress here. Okay, multiply fractions. Let me kind of put this up here as a text. When you multiply fractions, you should multiply numerators and denominators separately. Then simplify. Actually, say you can. Let me rephrase that. Not you should. You can. However, it might be more efficient. Simplify first by cross canceling, then combine the fractions. Okay. That's what I would recommend is to maybe consider cross canceling, just so you don't deal with big numbers or big expressions, and then combine afterwards. So like for 86, don't write it this way. I'm just going to just show you the first way I suggested. Like you could say 18 over 42, right? And sometimes some people have a hard time multiplying 3 by 14. And then you have to realize that 6 is a factor of both. So you get 3 out of 14. You could do that if you want. But what I would probably do is something like this. Hey, 2 over 14, 1 over 7. 9 over 3, 3 over 1. What does that become? There you go. 3/7. Yeah, that's it. And the reason why you could do that is because multiplication is what we call commutative, meaning that 2 times 9 is the same as 9 times 2, right? So I could just move the fractions around like this. The 9 and 2 could swap positions because now it's pretty clear. What's 9 over 3? 3. What's 2 over 14? I didn't get rid of 2 and 3. I got rid of 2 with 14. I got rid of 9. That's why I color coded. I got rid of, if you can see the colors. and then 9 over 3, which is 3 over 1, right? So let's, I'm sorry, say it again.
The next one.
Yes, you flipped the set. Yeah, sorry. I didn't move on to the next one. Yeah, so for next one, what you want to do, let me get rid of that, is when you divide, you must flip the second fraction, and then all else is the same. So 3 over 5 times 25 over 12, which is the same thing as saying 3 over 12 times 25 over 5, but you can just cross cancel. That's 1 and 4, 1 and 5. You get 5/4. So now we're going to do this with algebraic expressions. We've done it with numbers. Now let's do it with algebraic expressions. And then it's going to get even more complex on the next page, and then we're down to notes. So we should be done with these pretty quickly. So again, it's highly, highly algebraic, highly mechanical stuff we're doing. Let me minimize that a tad. All right. Let's not worry about excluded values. Let's just kind of just multiply these out. So I'm going to do A, B, C, D with you guys, and then have you guys try E and F on your own. So X minus Y is cancel, right? You get that. By the way, can I cross off those 3s? Yeah, good. Please don't do that. If you really want to get on my nerves, then do it. If you actually respect my sanity, then don't do it, because I will go a little crazy when you guys do that. Because you can't, right? We're beyond that point now. We've done a row of operations. We can't cross off those 3s, right? So be mindful. But I saw calculus students that still want to do that sometimes. I don't know why. Well, I know why, because they see it. It's tempting. But remember, we have to follow the rules, right? Because you want to do, if you have 4 plus 3 over 1 plus 3, right? If I have 4 plus 3 over 1 plus 3, I wouldn't cross those off, because now I get 4, but I'm supposed to get 7/4, right? So it's totally the same order of operations when you cross off 3s. Like now, if it's 4x times 3 and x times 3, go for it. Totally could do it. We will, and we'll get there in a moment. Let's look at B. You got to flip the second fraction, and something goes away. What goes away? That's it. Just 9x minus 1. That's all that goes away. Leaving behind x plus 2 or 2x plus 1. And you have to leave that alone afterwards. Okay. Here for C. It's a little tricky, but you can actually cross these off, because the top becomes this, and the bottom is right here now. So if I wait, oh my God, I can't believe that. Sorry. That's just me being tired, guys. My apologies. My apologies. You're like, what are you doing, Mr. Reed? Sorry, my apologies.
Yeah, it's fine.
Totally. And I didn't get canopy guys either. I should have actually. Should have brought some from my house. Oh, his son was a spy. It's his birthday tomorrow. Well, his birthday's actually next week, but we're doing the party tomorrow. It's a spy themed party.
Ooh, that sounds very exciting.
It is, yeah. And then and then my the middle one was Wonder Woman, and the youngest one just sort of ballerina type thing. I'll show you if I could upload the photos. I'll upload when I get a chance. Anyway, my apologies. 2m plus 3 is the bottom of the second fraction, because 3 plus 2m, 2m plus 3, same thing. Like 3 plus 5, 5 plus 3, same thing. So yes, we can cross those off. And the final answer is going to be 7 plus 4m over 3m minus 2. Oh, what I did, Emmy, is guys, quiet, please. Thank you. What I did was the bottom of the second fraction, I just rewrote as 2m plus 3. It's the same thing. 3 plus 2m, 2m plus 3, 100% identical. It just made it easy for me to see that's identical to the numerator of the first fraction. The numerator of the first fraction, the top of the first fraction, is 2m plus 3. the denominator of the second fraction, even though it's minus 3 plus 2m, it's still 2m plus 3. I just decided to reverse the addition because it's the same thing, and those go away. Or if you just see it goes away, just cross them off. You don't have to be as thrown out as I'm being. You could just cross them off. Now, for part D, I think Emmy said earlier we're going to cross off the y minus 2's. And yes, we will. But what I'm going to do is I'm just going to kind of write this out in a more drawn out fashion. Because how many y minus 2's do I have up top? Right. And then down below, I just have 1. You see those y minus 2's cancel? And that's it. That's the best we can do. You can leave it like that. If you want to condense it a bit further, I suppose you could say y minus 2 squared, y plus 5 over 3y plus 2. If you want to, you could. I don't care. But at the very least, we have to cross up the y minus 2 from the top and bottom.
Why is there a third y minus 2 on the top?
Oh, because you have y minus 2 cubed.
Oh, that's it's squared.
Yeah, it's cubed. And so you have to have 3 of them. But you could just make that a 2 and get rid of the y minus 2 in the bottom and have y minus 2 squared. That works also. Okay, go and try E and F. You're going to have to flip the second fraction in each case and combine, cancel, stuff like that. For E, you may want to combine first, then cancel. But for F, definitely want to cancel first.
So what's the answer for D?
Right here, right down below. Right there. Because I just ran out of space. Or just it's basically what you see here in the darker color. Just these are gone.
No, I got it.
Yeah. Yeah. Let me freeze the screen in case you guys are still looking at that. Try E and F. I'm going to do it on my screen as well. And we'll check in about a minute. Again, flip the second fractions. Don't forget to flip the second fractions. I know we're all tired. Do not FOIL. Because it's going to be hard to see what goes away. It actually makes it worse if you do that.
Like
Mhm.
plus of like whenever you keep things right, there's a 5x minus 2 on like the first.
So after you flip, then cross it off.
I'm saying the words. The
I got this.
5x.
Uh-huh.
Like this one, and then there's and the numerator of this one, and the other one, there's a 5x minus 2 in the denominator of the opposite, that cannot work certain opposite ones.
Hold on, let me take a look.
For your after E.
I don't know.
No, we want to cross cancel. We do.
2x.
Yeah, guys, we do want to cross cancel. We do. I'm getting there in a moment, guys. Hold on.
For which one?
4y over 2.
Give me a sec here. Okay, here's the answer for E. Just get 2x.
Did you just like multiply across?
Yeah, I said to do that first. I know I kind of went against what I've been preaching for part E. That's because I don't have binomials. I just have single terms, single letters. So it might be better to actually multiply things out first and then cancel afterwards. And I noticed I compartmentalized it, the numbers, the x's, the y's. And I took care of it after that.
Yeah. Well, I get, no, like, after this.
That's properties of exponents. That's what you're doing.
Okay.
We're good?
Yeah,
Cool.
it's like, looking.
So that's why.
I would like so I love the ground. And we're now like, I'm just like. It does not fit in the
Okay, here's part F. Should come out nice and clean. Don't foil, please. Because you can make it worse. So the first fraction I left alone, the second fraction I flipped. After I flipped, I saw an opportunity to cross off 3 pairs of things: 2x minus 3, 5x minus 2, and x minus 4. Leaving behind 3x plus 1 over 2x minus 8. Remember, 2x minus 3 squared is twice in the first fraction.
Writing it out more than one.
Okay, we're okay with that?
Yeah.
All's good. All right, let's keep moving. All right, 88 gets a little intense. All right, let's talk about 88. That gets a little intense.
If F not 10.
Oh, these are more intense because you have to factor. They're already factored for you in F. You mean F in the previous page, Jimmy, right? Yeah, no, these are more intense. All right, so let's do this. Let's look at part C. Let's flip the second fraction. So have 5x minus 15, 3x squared plus 10x minus 8 times 3x squared negative 8x plus 14 x squared. Oh my gosh,
Oh, wait.
dude. Oh, bro, you're on it, man. Look at this guy. Okay, so far I flipped, right? Yeah. Let me ask this question. What do you think is the easiest thing to factor first? Probably that one. And probably the 5 out of this as well. Yeah. I'll do that first. So you get this. Yeah, there's a lot of, I told you, it does get pretty intense with factoring. And the bottom becomes this. Yes, 100%. That's why we're doing this. And it's a skill set that we need in our toolbox as we move forward in math. Sometimes we have to simplify things to do other math to this stuff. So we have to be able to do this quickly. Or not quickly, but just smoothly. I think it's a fair way of putting it. Okay, so again, guys, quiet please. The intention is that things will cancel. Okay, so when I write these problems, and just so you know, guys, quiet please, when I do write these, well, actually, we already wrote this task. So with me and the 3 other Algebra 2 teachers, we literally reverse engineer the process. I mean, we know what we want as a final answer. Then we kind of say, okay, well, then what polynomial should we get so that things will cancel out nicely? There's an intention, just so you know. We're not just going to do some random polynomials. They'll just factor nothing cancel. Ha ha ha. No, we have to. I know we don't laugh at you guys. Maybe I'll do it through a test. No, no. We have to have things cancel, right? So here's what I'll do. Let's factor one of these guys to see what happens. You guys should know what to do. Okay, what 2 numbers multiply 12 add to -8? Good, yeah, awesome. Thank you, Fernanda.
Where factoring has to be foundational.
Thank you, Jimmy. I couldn't say it better. No, we have to multiply 12 and add to -8. Yeah, that's so hard to read. Okay. Yeah, well, I could take out x from here. 3x. -2. So say again, Jim, what do you get?
3x minus 2 and x plus 4.
Perfect. Thanks so much. Okay. So we had to do a little bit of work to factor that, right? Now, if I look at the next one, I'm thinking, oh, I gotta do this again, right? No, you don't. So here's the deal. Okay, girls, thank you. Here's the deal. Once you have one of these factored, you kind of suspect that I might need 3x minus 2 to come out from the bottom. So let's just take a leap of faith and say there's a 3x minus 2 here. Okay, just because that would be lovely if that was 3x minus 2. Well, if you think about it, if I put a 3x minus 2 on the bottom left, this has to be x, and this has to be, yes, what was that? Sorry? Oh, was it x minus 2? Sorry, did I make a mistake? Oh, my bad. Sorry, my apologies. Thank you again for catching it. Alberto, you're supposed to catch that. I was depending on you, dude. Oh, man. Okay, my apologies. Okay, yes. Now what happens here? Let's look at the second. Let's look at the lower left. 3x minus 2 and x plus 4. Right? Because here's the deal. I need to have if I have 3x minus 2 in the bottom left, there has to be an x plus 4, so that it comes back to 3x squared plus 10x minus 8. 3x and x is 3x squared, -2 and 4 is -8. The middle becomes 10x. Does that make sense how I got that? Yeah, so you don't have to, guys, quiet, please. Guys, I need to focus. This present tense focus. You don't have to go through the whole process of the diamond in the box. If you realize that these are going to probably be the same, let's take a leap of faith, make that 3x minus 2, and this has to be x plus 4. So now things will cross off very nicely. Well, actually, only one thing two things cross off. Those cross off, and those cross off. So you should get 5x minus 2 over x plus 4 squared. Okay. So here's what I'm gonna do next, guys. Okay, guys, I need you to focus. I'm gonna have you guys try the next. I'm gonna have you guys try the next 3 on your own. I'll do them. We'll compare in a few minutes, and then we're done with the notes. So go and try D, E, F. Very similar factor. Okay, factor, and we'll go through it. Okay. I'm gonna do D next. What do you need?
My eraser dropped.
Probably under someone's backpack. Do you need an eraser?
Like dropped off my pencil.
Does she hate that?
I do hate that.
Happens to me all the time.
Oh, I found it.
See? Told you I had a backpack.
Hey, Cons.
And Emmy, I'm gonna need my charger back. My battery's about to die. Emmy, I'll need my charger back. Yeah, my laptop's about to die, so.
I'm coming back.
Just like this.
Oh, thanks, appreciate it.
Thank you so much.
Yeah.
Are you on the news?
I'm gonna show you part ED in just a moment. All right. Here's part D. Let's think about it. Oh, so much better. Okay. So think about it, guys. For D, 12x minus 18, I can take out 6, 2x minus 3. The bottom's pretty easy, x minus 5, x plus 3. On the right fraction, x minus 4, x plus 3. Now the bottom's a little tricky because it's 3x squared, but 3 is a common factor, pull it out. X squared minus 3, x minus 4 is x minus 4, x plus 1. X minus 4 is cancel, x plus 3 is cancel, 6 over 3 is 2 over 1. And then combine it and you're done. So you want to be incredibly methodical in this process. Factor, pull out common factors, factor trinomials, whatever you got to do. Cross stuff out, bring it together at the end. So that's part D. Go and try E and F now. I'll do E and F as well. Remember for F, you got to flip the second fraction. All right. So let's.
So tough out there. I know.
Hey guys, let's focus. We're at the home stretch. I know it's Friday afternoon. Ah. Questions about D before I change the screen? No? No questions about D? All right. So which one? You guys quiet? There's a question. Girls, thanks. Emmy and Kate, thanks. And I need you. What do you have? What's the question about D?
I think it's factored wrong, but I don't know, she got like a.
Let me. I'll come take. You might have. It might be something I just need to take a look at. Just give me a moment.
Oh, is that the answer?
That's the answer for D.
Yeah.
I'll come take a look.
Okay.
All right, for E. Just a prime for you guys. So that's pretty easy, right? So here's Emmy, thanks. All right. No worries. I know it's Friday, I get it. Okay. So let's think about it. Before you get too carried away with the problem, some people think, oh, let's just factor this first. No, don't do that. Do the easy one first. That's the easy one. X plus 7. Emmy, I need you to focus. Thank you. Emerson, please don't talk to her. Enough, stop. No more talking. Let me finish. We're at the home stretch here. Let's finish strong. This ends week. All right. So x plus 7, x minus 3. Okay, we're good. Do that first. Why should I do that first? Do you see a 7 as a factor of this? Potentially, right? So what I'm going to do is I'm going to make this x plus 7, taking a leap of faith. If that's true, what am I going to put in that other parentheses? What do you think I should put in there? Probably 5x and probably -1. Does that work? It does, right? It does, because think about it. It gets you 34x in the middle. Now what goes away? Look at that. See how nice and clean that comes out? So I didn't have to do the diamond and boxing. I didn't have to. It wasn't necessary because I took care of that first. So on our test next Friday, if I see you getting stuck, like mystery, like I'm doing this is driving nuts. Like I'm like, no, do that first.
Wait.
I'll guide you in that way because it's much easier to do that first, and then you can factor the other one more easily. Okay, let me back up, guys. All right. No, it's okay. It's all good. Okay, this is the beauty about Zoom. I could do this. See? Okay. So notice how the second fraction at the bottom. So at the bottom of the second fraction, I factor that. So I went within the intent that x plus 7 is probably a factor in the top left corner. So by doing that, then what's gonna be in the other parentheses? It has to be a 5x and has to be a -1 to make it work out. It does because I get 34x in the middle. Now things cancel it nicely. So it's a time saver, and also you're just being more efficient, and you're not burning yourself out by doing harder math, because I'm trying to help you guys preserve your mental stamina. All right, last one. Sadie, go ahead. Sure, yeah, go ahead, yeah. Okay, last one's finished. I'll do this together with you guys. Okay, it's F. All right. Let's be smart about this. X plus 4. Jimmy, stop. Jimmy, stop. Stop. Jimmy, can you stop talking? I know you're talking math, but just let me finish. Thanks, appreciate it. Okay, I did easy stuff first, right? What do you guys think about what do you guys think about 4x squared plus 20x plus 25? 2x, 2x, 5 and 5, right? Does that make sense? You guys remember that? When you have perfect squares, you can do square roots of those. And if you FOIL, you do get 20x in the middle. Now, things should come out nice and clean. What do you think I'm going to put in the top left corner? Knowing that I should get things canceling. What do you think would be a smart one to just kind of just put out there? 2x plus 5, exactly. And then if you got 2x, I better have a x. I better have a negative 2. Oh, guess what? I do get x in the middle. It works. And look at that. Things come out nicely. Those go away. Those go away. Oh my gosh, look at that. All these things go away. It's lovely. And that's what we want. We want that to happen. This builds more confidence in your answer. Okay. Okay, good. We got plenty of time. Okay, good. This is awesome. I don't know if I'll maybe I'll wait till Tuesday. Actually, do you guys want to know what's on the test really quickly? I mean, I don't know if I have enough time to squeeze that in. Just those 2 parts. The video for I'm not sure which video. I did do a D period. Just so you know, there's 2 questions. It's going to be graphing.
I thought there was no graphing. Is that
No graphing in the current units. Graphing old stuff. Yeah, exactly. Graphing old stuff. Yes, exactly what Michelle said. Exactly what you said. No calc. Yeah, well, I'll have more details on Tuesday, but graphing old stuff in vertex form. So it could be like x squared. It could be apside of x. It could be x cubed. It could be b to the x. It could be root x.
Usually the first one.
It could be any of those. Could be any of those 6 graphs. For part 2, I think there are 4 questions. 6. Come on. I don't know where. Here it is. 3, 4. 1, 2. It's 5 questions. You know what? We'll just save this for Tuesday. We're not a little too rushed right now, so right. Let's stop it.